Alrighty, y'all. We're going to take the cube root of 125 x to the fourth. What do we do first? Separate it. And then, give me 1 second. So we're going to separate it into all of our pieces. And then x to the fourth. And then we can birthday cake 125. So we got 125. What is our smallest prime? Pull out of 125. There's actually two options you could do. Five. If we pull out 5, what do we get? What'd you get? Not 25. What'd you get? 125 divided by 5 is? Oh, it is 5. 25. Sorry, I was thinking something else in my brain. Okay, and then when we pull out of that? Wait a minute. Yeah. Oh, I'm thinking of 75. My brain. Sorry, guys. And then 5, and then we get 5, and then we can pull out one more 5, and we end up with 1. So what is our third root of 125? 5. And then our x to the fourth, our cube root of x to the fourth. X to the fourth is x times x times x times x. What can we pull out for a cube root of x to the fourth? 3 x's. Yep. So this can become, this is x to the third, right? Right here. And x to the third, cube root of x to the third is just what? X, right? So what do we have left in our, what do we have left in our cube root? What's left over in our x's? What did you say? Yeah, just x. Okay? So yeah, your final answer, 5x cubed, not x cubed, sorry. The cube goes with the root. Cube root of x. Okay? Oh, I'm sorry, guys. I didn't realize I was zoomed in. There we go. All right, does that make sense? Everyone good on that? Okay. Fourth root of 32x to the 8th. What's our first step? Split it up, separate it. So we got 32 times x to the 8th. Fourth root of x to the 8th. What is the fourth root of 32? Well, we can birthday cake that as well, right? We're going to do 32. What's our prime? What's a prime we could pull out? 2. And then what do we get? 16. Thank you. And then what can we pull out of that? Well, what do we get there? Yeah, we get an 8 and then 2. And then what do we get next? 4. 2. Yeah, thank you. 2, 2, 1. Okay? All right. So it's the fourth root. So how much is going to be in our group? 4, right? We want 4 2's. So we've got a 2 out here. And then what is left over in our radical? 2. Yeah. It's what's left out up here, right? Okay. And then...
Y'all, I'm hearing it again. Turn the music off. I can hear it from here. It's coming from this general direction. Music off. It's super rude.
And then x to the 8th, fourth root of x to the 8th. If you do, what'd you say? X to the 4th. But if we do x It's going to take a lot. X times X times X times X times X times X. 1, 2, 3, 4, 5, 6, 7, 8. We're doing groups of 4, right? How many groups of 4 can we get with 8 x's? 2, right? So not x to the 4th. It's super close, though. I see what you're doing there. But x to the what? X to the 2nd. Yeah. And then we end up with 2x to the 2nd. We just rearrange it so it looks a little bit neater. Nope, that's not what I wanted. 2. There you go. All right, everyone good on that? Cool. Okay. Flipping your workbooks, page 333. We're starting 6-5 today, which means I need mine. We're still working with radicals, but kind of just doing a more in-depth thing of what we've been doing with radicals. Specifically, the lovely product and quotient property. Okay? So page 333. Just waiting on a few people to get their workbooks out. $333. You're good. You're good. I'm not looking at you. Okay. So today we're talking about properties of radicals, involving these kind of work for all roots, which is really beautiful. Okay. The only thing to notice, if you don't like reading math and words, then the big thing you're going to want to note is right here, okay? Is that the nth root of a times b, just like we did in our bell work, you can split it up into the nth root of a times nth root of b, okay? But if you look below that, we can do the opposite, which means if we have the nth root, if we're given this part right here, this second part, we can actually combine them if we need to. So like the square root of 12 times the square root of 3, if we're given this, if they have the same index, right? If they have the same index, which means they have the same number as their root, then you can multiply what's on the inside. And in this case, square root of 12 times square root of 3 is the square root of 36, which is beautiful because we know the square root of 36 is a perfect square, right? It's 6. That's awesome. Okay? And then on the second example back here, we got the cube root of 4 and the cube root of 16. So we really don't know cube root of 4, cube root of 16. They're kind of meh type numbers. Those would be things we'd have to plug in. But we can multiply what's on the insides because they have the same index. They're both cube roots. And get the cube root of 64, which is a perfect cube, which is really cool, right? So the same thing with the product property we can do with quotient property. Quotient property, typically, the word quotient usually is, what's the word I'm looking for? Is related to what? What operation? Dividing, right? So product usually deals with, or most of the time always deals with multiplication, and then quotient deals with dividing, okay? So down here, again, in this portion of words, you've got, this is the really important part to notice, okay? So the nth root of some fraction, we can split that up into the nth root of the top divided by the nth root of the bottom, okay? Now there's one thing. The nth root of the bottom, aka b in this instance, can never be 0, right? Because we can never divide by 0. So take note of that. And then we're always going to want to simplify that as much as possible because in math, we don't like radicals in the bottom, okay? We don't like radicals in the denominator. So in this case, if you look at our examples, they simplify them as much as possible. So we've got x to the 4th over 25, the square root of x to the 4th over 25. We can split it up into the square root of x to the 4th over the square root of x, or 25, which, beautiful, we know the square roots of both of those. And then as you can see, cube root of 27 over 8, that's a funky fraction. So if we take the cube root of both 27 and then cube root of 8, we can simplify that a lot more nicer, Okay? Everyone good with this? We're gonna do some examples in a second, I promise. And then on the same page, right underneath that, it talks about the simplest form of radical expressions. Biggest thing you want to note is that we always want the index n to be as small as possible, and that we don't want any factors. Okay? No factors. So if I have the square root of 18, I can factor things out of that, right? What perfect square multiplies to 18? 9. 9 times 2, so this is the same as 9 times 2, which is the same as 3 times the square root of 2, right? So we never want to leave it in this form. We always want to simplify it as much as possible, okay? And then we always want there to be no radicals appearing in the denominator. Cool? Okay. Exercises. You guys are going to skip to example 1. We're going to work with B. It's the square root of 75, x to the 12th, y to the 7th. It's the very bottom of that same page. And then if you want to work it out as I do it on the board, as we do it together, I would highly recommend using your note section on the side, okay? So, or you can fill it in the little spaces they give you as well. Either or, whichever works best for you, okay? So, what's our first step? Separating. So we can separate this into 3 beautiful parts, right? So we've got the square root of 75 times the square root of x to the 12th times the square root of y to the 7th. 75, is that a perfect square? You don't know? No, it's not. So what we can do is birthday cake it. All right? So what can I pull out? What prime factorizations can I pull out? 5. 75 divided by 5 is? 13. Should be close to that. It's not 15. Is it 15? Is that what you got? Okay, sorry, I was thinking it was 16 in my head. Yep, 15, then what can we pull out from there? 5. Okay, what do we get up here? And what do we pull out of there? And what do we get on top? 1. Okay, so 75 is what? What do we have here? We have 1 pair of 5s. 5 square root of 3. Good. All right, x to the 12th. What times what is going to give you x to the 12th? That's what you want to think of. X times what? 6 times 2, we could do that, but remember with exponents, if we did x to the 6th times x to the 2nd, what do we do with exponents when we're multiplying their integers? We add them. So this would give us x to the 8th. So that's a super close idea because 6 times 2 does give you 12. But in this instance, it doesn't work. So what 2 things add to 12? And they have to be the same. Yeah, x to the 6th times x to the 6th. It's going to give us x to the 12th. So what's the square root of x to the 12th? X to the 6th. Does that make sense? Everyone okay with that? Yeah, no, maybe so. Questions? All right, we're going to do this with the y as well. So y to the 7th. Is 7 equally divisible by 2? No, it's not. Yes, it is 3.5. But that's not what we don't want. Decimals. No, not right now. We want whole numbers, okay? So y to the 7th. What 2 numbers? What's the biggest number that adds up to 7? Sorry, how am I wanting to phrase this? 3 and 4. We could do 3 and 4. Is there something bigger than 4 that adds up to 7 that's divisible by 2? 6. That's a good one. If I have y to the 6, what am I multiplying by y to the 6? Y to the what? You want to get back to y to the 7th, y to the 1st. So you don't really have to write the 1 there, but you can leave it. So, yes. Yeah, what's up?
So, okay, so if it's not, like, if you can't divide it into two parts or whatever, like, do we have to do 6 and 1, or could we do, like, other numbers?
No, you always want to take the largest number out of it. So if I have m to the 15th, the square root of m to the 15th, what number do you think I would use? 14 and 1. Yeah, I would have m to the 14th times n. Does that make sense?
Yeah.
You're always going to find the next largest number that's divisible by your index, okay? So if my index is 3, though, with 15, what would be my number? Yep, 12. Oh, shoot. Sorry, guys. I would want this to be 12, m to the 12th. Okay? Does that make sense? Okay, cool. All right, now I just got to undo all this. Can't erase. That's okay. Perfect. Okay, so now back to the y to the 6 times y to the 1. What's the square root of y to the 6th? Y to the 3rd, yep. And then what do I have left over in my square root? Just y, yeah. And then one more thing, we always want to rewrite this as nicest as possible. So we always want to take what's on the outsides of our roots and put them right next to each other. So 5, x cubed, y cubed, or why did I get x? It's supposed to be 6, sorry. 6, x is 6, y to the 3rd. And then what goes in my root? 3y, yep. We can combine these two back together inside one root, okay? Make sense? Yeah.
Like the y to the 3rd, wait, how did you get that again?
The y to the 3rd. I took the square root of y to the 6th.
That's what I thought.
Yeah. Does that make sense though?
Yeah.
Okay. How are we feeling about this? Yes. We want it as an even power, so that's divisible, okay? Cool? Yeah.
So both the root and the y can combine because they're both under the.
Yeah.
Okay.
Exactly. Yeah.
So, how is that? I think you already said this, but I wasn't like, okay, wait, so the 5x and the, like, how did that, like, into that again? Like,
All of this bottom one?
yeah.
Oh, I just rearranged this. You could leave it as this. Seriously. You could. But we always want to rewrite it as nicest as possible, which means we always want anything under a radical to be last.
Okay.
And everything else on the outside to be first. And we typically always go numbers, integers. Okay? Does that make sense? All right, everyone good with product property? Everyone good with this slide? Okay, so we're gonna do one. Flip to the next page. And I'm gonna have you guys do a problem on your own real quick for 5 minutes, and then we're gonna do it together. It's gonna be top of 334, okay? Top of 334, it's problem A, part A, okay? I'll give you guys about 5 minutes to do this on your own, and then we'll come back together, yeah. Yep, take a pass. It's like really raining.
Yeah, it's really good.
Yeah, if you don't have enough room on your paper, you can always go put it in the notes section.
Absolutely. Yep. Here, if you want to be able to see it, let's do it this way.
Oh,
Pull over.
okay.
You can also do it on your desk too. You like to do that? Right? Oh, yeah. It does.
Okay.
Go for it.
Okay.
I know.
First, she said like separate something. So separate, okay, wait.
It was a fourth root up there.
So wait, what do I do with like this number again? Like this, like, I know.
So steps are the same,
Okay,
okay?
okay.
So started exactly the same. Mhm.
Yeah.
Right, and then, what, so,
So put your teeny tiny fours inside each of those check marks.
like, right?
No, inside here, yes, yes.
I didn't, that's what I didn't write like the little numbers, right?
Yeah,
That's
well,
why.
it's because that one was a square root, so we didn't have a little number.
That's why,
Okay, yeah,
so
square
then-
root has an invisible two there.
The cake thing, but it's.
It's a 4, so are we gonna be able to pull anything out of there? Because when we are doing numbers, like roots like this, if we, like, are you a birthday cake person or are you like a peppermint cake? Birthday cake, so let's pretend that we said 4 through to 16,
Okay.
just pretend for now. So if we birthday cake it, what am I pulling out of 16?
Or two.
2, yep, so it would be 8. Yeah, right? All this means is that, so if we did square root of 16, we would do pits, right? Fourth root means any groups of 4. So 1, 2, 3, 4, 2. So the fourth root of 16 is 2. Okay, that's all this is, it groups up. So is there anything inside of 4 that I'm gonna have 4 groups of? Well, is 1 times 1 times 1 times 1?
Oh, no, I guess not.
Right, right, right.
No.
So it's not. So this is, he's just coming out. He's not doing anything.
So then what do you do if one person off?
He's gonna stay in the house.
Oh.
He's gonna live in the house.
Can we?
Okay, so then we're gonna look, so for the x to the fifth, how many groups of 4 can I get out of x to the fifth? 1 group of 4, right? And how many are left over? 1x. Because this is 1 group of 4 and 1 left over inside the house. How many groups?
So wait, you take it out
If we take it out, I can make a group of 4.
Okay.
So for y to the
They
20th,
can go 5 times.
I can make 5 groups of 4, right?
Right.
So it's gonna come outside the house, so you ready this time?
Okay.
So it's coming outside the house.
Oh, coming outside
If,
the.
yep, if I can make that many groups, if they come
You just
outside.
write it right next to it.
Yep, right next to it. And how many groups? Yes,
That's it?
yes,
Are you for real?
yes.
Okay. Okay. Yeah.
I was gonna say, you got it.
Okay.
It just takes a minute to process,
Yeah.
okay? That's, absolutely, write it down. And then, yeah, feel free to dry erase all over the desks. That's why they look really grungy sometimes.
Oh, yeah, I
It's,
didn't know.
yeah. It's dry erase.
I've never been a teacher.
Oh, it's my favorite thing. I will, when we get into like study for the tests and stuff, I just have dry erase markers in my pocket and I can write upside down on the desk.
Oh, that's fun.
Cause that way I can sit across from you guys and still show you work.
Thank you.
I love it. Anytime I hear. Good question. Like, yeah. Yes, 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 yes. Yes.
I don't know, I'm just like super
Okay.
balanced.
Okay.
So just five. Do you
Yes.
separated?
Yes.
And then that looks right, right?
And we're doing fourth root. We're doing fourth right here. So fourth root of 4. Is there anything inside of 4 that I'll be able to circle a group of 4 of them?
All right.
Stays inside the house.
So the fourth root of 4, x to the 5th, y to the 20th.
That stay inside.
What is our first thing we can do? Separate. So if we separate,
Yes.
we get the fourth root of 4
Can I take that?
times the fourth root of x to the 5th times the fourth root of y to the 20th. All right. Can we take the fourth root of 4? Can we take the fourth root of 4? No. So what does it stay as? Fourth root of 4, right? Okay, what about fourth root of x to the 5th? Yeah, we can. We just work through it. What do you get? X times what?
And there's the x. This is my one group of x.
Times the fourth root of x.
Okay.
So x to the 5th
So then on my
is the same thing as x to the 4th times x, correct?
right?
Right? And we can take the fourth root of x to the 4th, but we can't take the fourth root of x to the 5th.
How many groups of 4
Okay?
can I make?
And then our x, this lonely x out here,
Y.
He just stays in the root, okay? And then 4th root of y to the 20. What do we get? Y to the 5th.
Totally fine, yeah.
Okay? And then we want to rewrite this as x times y to the 5th times the 4th root of what? Not just x, but 4x. Yep, we want to bring both pieces back together, okay? No, you're good. All right. And then we're going to go do a division one now, and it's on the same page, but for me, I have to flip pages. Okay. Part B, if you go down that same page you were just working on, it's part B, about halfway down the page. Same thing with the multiplication one. If you need to do it on the note side, on the side, and not with how the book writes it, that's totally okay. But if you want to do it with the book, that's also okay. But we're going to do it just here on the board without directions or steps, okay? What's our first step? First step? Separate it. Yep. 4. And in this case, we've got 4 different pieces. We've got 80, we've got y, 256, and we've got z. So we're going to separate it in 4 different ways. We're going to have 4th root of 80 times the 4th root of y to the 14th all over, keep that division bar where it is, 4th root of 256 times the 4th root of z to the 4th. Cool?
Correct.
Now that we've separated, we got to start piece by piece. So start with the top, go across the top, go back to the bottom, and go across the bottom. So the 4th root of 80. What is the 4th root of 80? Or how do we find the 4th root of 80? Weekend birthday cake. Woo! What is something I can pull out of 80? 2. And then what do I get? 40. And then what do I pull out again? 2. 20. 10. 5. 5. And then we got 1 on top, right? Everyone okay with that? So we need a group of 4. What's our group of 4? 2. So what do we end up as the 4th root of 80? 2, not square root, but 2 4th root of 5. Yep, don't forget. It's totally normal. I totally get that. 2 5th root of, not 5th root, dang it. 4th root of 5. Yep. And then 4th root of y to the 14th is our next part. Can we evenly divide 14 by 4? Y to the 7th. Y to the 7th power. But that's if we're doing square. Because y to the 7th times y to the 7th does get you y to the 14th. Does that make sense? Yeah. But we're doing the 4th root. So we need something to multiply by 4 times, okay? I know. I don't like it either. It's gross. So, what is the next largest number that adds up to 14 that's divisible by 4? Next largest number that adds up to 14 but divisible by 4. 12, yep. So we're going to want y to the 14th, dang it. Y to the 14th equals y to the 12th times what? 2. Y to the 2nd, yep. And then if we're taking the 4th root of this, what can we take a 4th root of? 12. What do we get? Y to the 3rd. What's left over in the root? Y to the 2nd. Okay? That's our top. I'm going to erase the birthday cake over here just so we have more room. Is everyone? Yeah, what's up? Yep, take a pass. And then, can I erase this bottom part? Yeah. Okay. So then, the bottom part, sorry. Bottom part. 4th root of 256. Using a calculator, what do you get? Using a calculator to find the 4th root of 256. 4. 4th root of 256 is in fact 4, which means that 4 times 4 times 4 times 4 equals 256. Beautiful. We could have birthday caked it, but that was a lot of work. No, we don't want to do that. So you guys know how to birthday cake pretty well. All right, and then our last step, z to the 4th root of z to the 4th. This one's really fun and easy. Not z to the 4th, but just z. Just z. Because we've got z times z times z times z. One group of z, one group of z to the, one group of 4 z's, and we pull out our z. And that's it. We could leave it like this. We could, if we wanted to. But we're good mathematicians, so we're going to rewrite this. What's the nice way to write this? What do I want on top? Okay. Y to the 3rd. 4th root of 5y squared all over 4z. Good. I can simplify one more time. What's the last time? Can someone grab the phone? What'd you say? 1 for 2. Yep. And what does my 4 become then? 2. Okay. All right. Everyone okay with that? You've got still like 10 minutes. Perfect. So you guys are going to do one more problem. It is the problem right underneath this. It says write the simplified form of, and then you're doing a square root this time. Okay? I'll flip to it. Can I flip from this page? Is everyone okay? Okay. So it's right underneath there. So you guys I'm going to give you guys 5 minutes to work on that on your own, and then we'll go back through it real quick right before the bell rings, okay? Does anyone have questions? Cool. Okay. You good? Okay. Wrong way, Alexis. Miss Rice. Wow. Okay. It's this one right here.
The whole design, this one? Okay. So, some general questions. We're gonna break it, and then we're gonna break it. Straight thing, okay? So we're gonna take our square root of homeboy, 9x38, y13, holy scan qualities.
So,
Imagine this was a photo. Oh, sorry.
part is it hard?
Okay.
I guess I'm just like,
So, first things first.
I don't know, I guess I
Yeah.
have so much information. Okay. Just like,
Square root,
Yep.
nine
So like,
x8,
I guess the best way
y13.
for me to
Oh.
understand is like,
Square root,
in like
25x squared.
simple stuff.
That's okay.
Then you're into
Simple steps is your way of looking
exactly
at
this
it.
process with that,
Or do I need to?
exactly this process with that.
Right, doesn't matter which one you do first.
Yeah. Nope.
That would be okay.
So, what do I do?
So,
That's
you don't have like a advice of like which one to start with?
This one's nice and easy on this one, for this.
Okay.
But no, it genuinely does not matter which order you do it in, as long as you don't flip flop where they are. It does not matter.
Oh, this is square root.
No, it's totally fine.
And then,
Square root on the sky too. Oh, yeah. As I say, I'm just saying, totally fine. Except for-
and then 1 square root 2, that's what I
why did the 13th? Not cake, but. It's okay. And then, what? Next largest number out of the 13th. Oh, yeah.
Separate.
Yeah, separate. Okay.
Okay. So then, same exact thing we did up there. So I'm looking at my denominator.
Okay.
I could not have done that if I tried. Alright, so we're looking at a denominator. What is the square root of 25? What's the square root of x squared?
So we're gonna have y is 6.
Okay, x squared. How many pairs can I
Why
put?
did the
One.
why did the one?
Okay.
That's what I thought.
Uh-huh.
Does that make sense?
That's okay.
So.
There's no
this
shame in
becomes
being
why
wrong
did
on
the
it.
one? So if it's not.
Okay,
different,
so that's
then
my denominator.
That's fantastic.
So then we're gonna look at our numerator here. Same general process. This one's got a lot of pieces, so if it helps, break it apart.
By
X be 8.
Okay, by
Square root of y is 13. This one, it just had two little pieces, and we could see they were both perfect squares. Like, you don't have to break it apart. I am never gonna do this, you just break it down. I'm not that much of a jerk. I ain't got that. If it works for your brain, we're cool. So then we're gonna do all these pieces.
Oh,
What's the square root of 9?
There you go.
You're right.
So am I done with the problem?
And then, okay,
as a
wait,
whole?
so then,
Uh-huh.
okay, so you split it in half, right? Like, don't you?
Oh.
Yes.
Okay.
Because
Yeah. And then
square
I
roots have this
was done.
invisible 2 here. 8 divided by 2.
Rewrite it a little simpler.
So we have x to the fourth.
Yeah.
Uh-huh.
Um,
Yes.
And
Uh-huh.
then,
This one's a tricky one.
okay, yeah, so wait, is this the one where it's like the 12 and the 1?
Yes.
Okay.
So we're gonna do the square root of y to the 12 and
You're
y
good. You're
first.
Okay.
Because what is the square root of y to 12?
Wait,
Yeah,
okay,
you
wait,
did.
hold on.
You are good. That is it. Hold on. That makes sense?
So we have to do a clarifying question?
No, wait, I know, hold on.
Okay.
All right, everyone about
Okay,
there?
no, wait.
Everyone good?
How many
Okay.
pairs of socks
That's what,
can
yeah.
I have if I have 12 socks?
Well, wait, is this everything we designed? Okay, 6.
Yes. Why?
All right. What's the square root of 9?
How does this go?
3. So, I mean, we could go through this again, and you could separate just like we did up here, if you wanted to. But just because we're running out of time. Square root of 9 is 3. And then what's the square root of x to the 8th? X to the 4th. All right, and then what's the square root of y to the 13th? Y to the 6th times square root of y. So with our y to the 13th, we want to define the next largest number that would add up to 13 and be divisible by 2. That's y to the 12th times y. There's a little 1 right here, right? So 12 plus 1 is 13, and 12 is divisible by 2. Okay? Is that making some sense to everyone? Good. Okay. And then we got the square root of y, which looks like an x right now. Sorry. I literally hate that. And then square root of 25. Crickets. 5. There we go. And then square root of x squared. X. There you go. There's one thing I will point out. You don't have to do this. But if you want to get into the literally most simplified form, you can cancel an x out and the 4 becomes a 3.
Don't worry about that.
Have you guys done that before even? Yeah. Okay, just making
It's
sure.
been a while though.
You don't have to worry about it, yeah. All right, homework is on McGraw-Hill. Do it on McGraw-Hill. You don't have to, but please do it on McGraw-Hill. It's 1 through 21 odd and 55, and then your test is a week from tomorrow. Sound good? Yeah. Yeah.
So like I was doing this and I was like plugging it in.
Yeah.
And then for this one it said like it wouldn't go through.
Yep, because negative 2 plus 1 is what?
That's like -1, right?
Yep, and you can't take the square root of a negative number, can you?
Oh, is that why it says not like?
Yep.
Oh.
It should say like domain error or something like that.
Okay.
Does that make sense though?
Find it in here.
But does this